Welcome to the Excel portion of Chapter 14, problem number 13. It's a little bit longer problem, but this is a really good example of how to use the Excel OM software. So we'll go to Excel. We will go to Chapter 14, and we are doing MRP. That's the only one we use in this particular chapter, is doing the MRP records. So we're going to, in this case, the number of lines, again, as I mentioned in the previous Excel example, it's actually the number of components. And if a component's in there twice, you still count them as separate. So in the example for 1411, we had C in there twice. We don't combine them, but the software will at the end. So in this particular case, we count down. And we have 1, 2, 3, 4. So according to my calculations, and I'm going to double check, it is, well, there are 13. And I count 13 again. So just be careful with it. I'm trying to go through this exactly as if I was a student. The number of periods of time in this particular case is 12. We actually don't need that many, but we'll follow the, you actually only need 7, and you tell that by the parent, but I'm going to put in 12 just to follow the solution in the Word document. And we go, okay. Now, I'm going to take some time with this. This is the parent. So this is the 50 centimeter fan. And it's at low level code 0. Because it is the parent. Normally you only have one item that is at low level code 0. The next item is the housing unit. So the housing. So housing unit. Now, the usage per parent is, in this particular case, is 1. So the housing has usage per parent because you'll notice down below it doesn't have a number after the housing. But if you look down to supports in your textbook, then you will notice that the supports have 2. So the housing is 1 for each parent. The next item is the frame. The frame is not a child of the fan. The frame is a child of the housing unit, so we will indent that. Next, supports. So there's 2 per parent. And again, supports is a child of the housing, not of the fan. The handle, which is next. So handle. This is why I did not pre-do this. I have on lots of videos before. It's because this requires an extra step before you get into the Excel spreadsheet. So the handle is 1, and the handle is also a child of the housing. Next, this is the grills. Usage per parent is 2. And the grills are a child of the fan. So the grills are low level code 1. Next, we have the fan assembly. So we have the fan assembly. And the fan assembly is also a child of the fan. The fan assembly has 2 children, the hub and the blades, so we will enter that. we'll go hub. We need to, and there's one hub per fan, so we need to indent that. Now we're going to enter the blades. The blades are 5, and the blades are a child of the fan. So each fan has 5 blades. Next is the electric motor, electrical motor. The usage per parent for the remaining items happens to be 1 because there's no number in brackets after the motor, the switch, etc. And indeed, the electrical unit is a child of the fan. Next, we're getting close to being done this portion, and then we have more work to do on the next screen. So we need to, and you have to be careful with this. So there is a way to change it later, but it doesn't work nearly as well as if you're just careful at the start. And I'm going to go back out in a moment and just make sure that I've got everything coded properly. Next is the switch. And the switch is underneath the electrical motor, and almost finally, the knob. So just to follow the logic, this is an indented bill of materials. And so just to make sure I've done this correctly, fan is at level of a code 0. So only item is the parent. So it's the only item at that level. So it's the furthest to the left. The housing is a child of the fan. So it's indented 1 level. It is in our diagram. And there's 1 housing unit. The frames are a child of the housing unit, as are the supports and the handles, but the supports requires 2 supports for each housing unit. The grills are a child of the fan, and there's 2 grills, one for the front, one for the back, likely, for the fan. And the fan assembly is a child of the 50 centimeter fan. It has 2 children, and it has a hub, and then it has 5 blades. The electrical motor is a child of the fan. So the fan has 4 children, 4 direct children, and then each one of those children has children of their own. So the electrical motor is the parent for the motor, the switch, and the knob. And as you can see, there's, again, because there's no number in the brackets after motor, switch, and knob, it is defaulted to be 1. So I'm confident that we've got this done correctly. Like I said, it's quite challenging to go and modify it after we've done it. But if we get this set up properly, then you will save you a lot of time in the next diagram. So again, I will make this a little bit larger. You can do the same thing by going Control+ on your computer if you want to make it larger. So in this particular case, I've got some information that I'm going to need to enter. So we'll just go down in order. In period 7, I need 1,000 units. And it does all of the calculating. It goes all the way down here, multiplies, but that's not correct because we still have more information to enter. The lead time, anytime you see a lead time of 1, you don't have to change anything. So I'm only going to identify from here on out when we need to change the lead times. The on hand is 100 units. So you put that in. And the lot size defaults to 1 or lot for lot. And again, from here on out, I'm only going to identify components that have lot size that's different than lot for lot. So the housing is lead time of 1. It also has 100 on hand. So I'm going to put the 100 in here. Does all the recalculation, and it recalculates everything below. In this case, the frame, the supports, and the handles. Next is grills. So in this case, the lead time is 2. So I'm going to have to do this or change the 1 to a 2. And it goes by low-level code 0. So it doesn't go like you saw in the diagram. It doesn't go fan, housing, frame, supports, handle. It goes fan, housing, grills, fan assembly, electrical unit. So we'll get to the lower, it goes by the low-level code, which is the way it's done in industry. So in this case, we can see that we have 200 grills on hand. I'm sure you can appreciate if you actually had to calculate this by hand, like we used to show. Last time I showed this, how to do this by hand, is now actually getting to be, this is now 2020 when I record this video, it was getting close to about 10 years ago. And industry has used software to calculate this from way back. Like I'm talking in the 1980s and the 1990s, that far back. So in this particular case, we have a lot size for the grills of 500. So I'm going to change the lot size to be 500. All right. And you may remember I mentioned that in the video in the Word version of the document. So it's taking care of all the calculations for us if we're careful and enter it correctly. And you have to. When you're in industry, if you do this properly, then the software just calculates it. And that's the way it is done in industry. I've had students from the past, they've entered something wrong and then all the other calculations are wrong. So the fan assembly has a lead time of 3. The fan assembly has 150 on hand. And again, the lot size there is 1 for 1. The electrical motor, so it's kind of helpful that took the time and effort to go through this. I called it electrical motor, by the way. It's technically it's the electrical unit, if that confuses you, because then there is a motor. So in this case, I don't have to change anything. There's none on hand. There's no lot size, or the lot size is lot for lot, I should say. And the lead time is 1, so I don't even have to change anything. So that kind of saves me some time. On the frame, when I go back up, the only thing I need to change is the lead time is not 1. The lead time is 2 for the frame. And again, nothing on hand, and the lot size is the default. The supports, don't have to change that, but I have 50 on hand. And I have a lot size of 100 units. Like I said, not only does it change the calculations for that particular item, all of the components below this. In this case, there are no components below the supports, but if there was, it would recalculate everything. The handle, which is next, I've got lots on hand. I have 400 on hand, and the lot size is 500. The grills we've already done. The hub, in this case, don't have to change anything. The blades, I'm going to need to change the lead time to 2. And the lot size, they come in batches of 100. And again, you can put the zeros in for the on hands, but I'm just going to skip over that. It doesn't change any of the other numbers. So for the motor, I don't have to change anything. For the switch, the lead time is 1, but I have 20 of them on hand. And in this case, I buy them in lot sizes of 12. So I'm going to enter the 12 here. Calculates the next highest acceptable lot size, which is 888. The knob, the only thing I have to put in is the lot size is 25. Now, properly in industry, of course, you'd have the on hand, but that would normally already be done for you. and or it would have been done for previous examples. But if you're starting from scratch, if you're creating an MRP record for an item that has not had an MRP record, then you have to put in the on hand. And there's all our calculations. So just to scroll back up here, how do you read the MRP record? So I've gone over this before, but I'll go over it again. So for the 50 centimeter fan, I need 1,000 units in period 7. I already have 100 on hand. So if I do not order any, I'll have a 900 unit shortfall. So you take the net requirements would be like negative inventory. There are no scheduled receipts. In fact, in all of these examples, there's no scheduled receipts. And a scheduled receipt is simply you ordered it before, so it's on its way kind of thing. And so if you're sitting there and say, well, I ordered something, online and I haven't got it yet, then that would be a scheduled receipt. At the time of this recording, I ordered something last week. It will take about a month to get here. So I would put that as, if these are weeks, I would put that in period 4 to receive that item. And some companies also have standing orders where they'll order the same quantities. So rather than ordering the same amount of wine for a restaurant, because they use about the same, is they'll order, say, so many cases of wine for the restaurant, and they will then have that like as a weekly delivery as far as the amounts go. So in this case, there are none, but that's what it represents. So between the net requirements and the planned receipts is where you apply the lot size, which in case of lot for lot means the two numbers will be the same. And then between the planned receipts is when you receive it, and the planned orders is when you order it. You back it up by the lead time. So to go down to 1 here, in this particular case, to go down to the grills, you can see you have 200 on hand, but you need 1,800 in week number 6 because there's 2 grills for every 50 centimeter fan. So it multiplies that for you. And in this particular case, so you need 1,600, but you can't order 1,600. You have to order them in multiples of 500. And so 500, 1,000, 1,500, 2,000, and you always go higher. And the lead time is 2. So that's how you read the MRP record. And again, in industry, this is done by software. I'm sure you can appreciate all the time and effort. If I were to give this on a test and ask you to do it manually, this particular question would probably take you, say, an hour just to do the calculations. So in this case, we've done it much faster, even though I've taken my time explaining to you how to do this. And once you've got it set up, once you've got the program set up, all you have to do is start entering one number, the gross requirements for the parent. So I'll show you. I'm going to add this to the problem. By the way, this is not in the problem, but I just want to show you. So in period 10, you need 750. All right. So in period number 10, I need 750. All the calculations are done. That's it. So I added that just to be crystal clear. This is not part of the question. I just wanted to show you what would happen. So once you've got it set up, so whatever periods of time that you get from your forecast goes to your aggregate planning, your master production schedules, and then down to this level. So now we know on a much more detailed level how many of each individual component I need and when. The forecast, if you remember when you did chapter 4, was just very much of an overview. And you didn't forecast in this level. You just forecasted how many fans you were going to sell. And then we looked at capacity planning, and then we did aggregate planning, and now master production schedules and MRP records. So this is a longer presentation, but hopefully it was valuable for understanding.